Welcome back to my mustache. I'm going to show you two of the most important, in my opinion, GHPython nodes you need to create for yourself, and it's for those that have always, and we can make them into a WICKERSON Studio object because I use them quite often. I'll do it in the To The Point and Beyond series here, and we'll deal with the vectors and pump out those first two, which give us so much wonderful data. I'll build them with you from scratch, but basically, and for those that have always, avoided the maths, the sets, and the vectors in Grasshopper and tried to jump right into the curves and tried to do everything the way they kind of visualize things in the Rhino window. But let's get out of here. Take all these off to disable, and let's build those two great nodes that I'm talking about. So if that doesn't get you wanting to get started, I don't know what does. Let's jump into maths and get ourselves a node to start putting things in. Open up the editor. Simplify these to as much as we can. These are going to be pretty dead simple because it's not too much different than just going in and grabbing, say, the vector nodes and using, all the way through cross product, all the way down to rotating and reversing vectors. I have a little quote in there I have to get rid of. But you're going to import RhinoScript syntax as RS, and you're going to create a vector. And that vector can be, let's make that vector x, y, z, and that will allow us to import that. I should actually set that variable to something, and that's enough to start. And what can we do with that vector? Well, we're going to create a vector length, and we're going to have that vector length out is going to go directly to out, which is kind of nice, and that is going to use a function within RhinoScript.syntax. I'm just going to leave that hanging for a minute because we're also going to put within the same node a unit vector tool, which basically have a node that does everything, and you can draw from it whenever you want. Instead of having to go up to the ribbon tool and pull it down again, we're going to set that equal to RhinoScript, and we'll set our dot on that in a minute. We are going to produce a vector scale. This is the same thing I used to do with operators and make myself kind of a calculator. Well, this is kind of a vector calculator in my opinion. And I think this is a very good tool to get in the habit of. And we will have that set to an RS, and we will get their function in a minute. We're going to do a vector reverse and have that set to out. And of course, we have to put these into our node, RS, and we are going to have a vector rotate. You can continue with this. I mean, literally, it's going into RS and taking under the vector tools, typing vector and seeing all the options that come out. This is just a way of getting all your ducks in a row. And I think it's a very good tool for doing that. And that will be RS. So that is it. I will have to bring in a vector, but since I set this, I'm going to have some fun with this and allow it to be a float. X to be a float. I'm going to allow Y to be a float. And you can create your own vector, like your own creation vector tool, the same way you would create a vector. So this is kind of like tucking this in and saying, okay, let's create a vector X, Y, Z, and it will give you a vector length. But this one's going to give you a lot more jazz. So let's get in here and say what it's going to do. 2, 3, 4, 5. Oh, 3, 4, 5. And we'll let this one input. Let's just do a quick double click there. Copy, because we don't want to sit and type it all again. Paste. And we'll do a quick copy. And I would make yourself one of these. Why not? Do it. And then you're really getting around the play. And we're going to make 2 of these nodes because they get a little jumbled if they get a little too big. And even if we have a typo and you do this, you may not catch it, but maybe it doesn't even matter because the computer just wants to have reference to what's out, to what's coming out of the node. And then E, we're going to right click and have that there. And now let's see what we can pull out of here. Let's do the dot, and we will do a vector length. There's probably a function that does it, and all you have to do is input your vector. Pretty simple. I'll go down to your next one. Say, okay, I want a unit vector, so I'm probably going to do rs vector unit. Unitize. That sounds like it's probably the ticket vector. Easy ways of writing custom nodes. And you really are, I guess, getting ownership of your own kind of Grasshopper ribbon tools and your own kind of private user objects, and consider them plugins. I don't think anybody would buy these plugins, but they're there. Let's autocomplete and take that to vector. Sometimes you'll need something like the scale factor. So as soon as you see that and you realize it needs something a little extra, let's slip into here factor, which we could use to scale. And we could take that as a factor float, and we will just pop on something like 5.3, 5.8. So that's really going to accentuate that vector. Let's go into here and pull the vector reverse, and that just needs a vector. And you can go into the details if you like. And the last point will be vector out, vector rotate. And rotate obviously implies that it probably needs something. So as you hit this, it's going to need angle, degrees, and an axis. So you're going to have to provide that with something. And we could input an axis. That would be fine. We could go down here and say there's an axis because I'm going to need that. And that will be a line. And that might be one that we do. And I also want to get some numbers in here before we start. Just get our vector in order of where we want to send it. And we'll do this. Actually, I think I'll copy 3 times because I might want to set my x and y to very simple so I can check out my cross product and see if it looks right. So we'll just take x and y. We'll put it up to 100 and 100 and take that one up to, let's just do 100, 100, 100. That's fine. And then the axis will be a line which we will actually import. And I don't usually bring in containers. I like to construct them myself, but I can always construct a line and pop it in here. But for right now, I'm just going to hard code a line by saying, let's set one line to grid snap, jump on there to 0 and go out to, we could take the rotation right there in the Y. And if you can't get it on, you can always snap it. And that line's being registered. And just to keep that consistent, I think it's internalized because I've already set it, so that's fine. And so that's not too exciting, but at least it'll run. Let's go back to the editor and at least get that in there. We are going to need the vector. We will need the degree. And I usually deal in radians. And then we will need the axis. And that should work, but of course we still need within here, plus we're going to need a degree. Degree. And if it says degree, it should be easy enough to think about setting that degree between something like 0, 180 degrees. I could do anything. Like I said, I don't usually use degrees, but and you can put snapping on here if you want or whatever, but I'm just going to crank that up to 74 degrees, and actually 75 degrees sounds a little better. I think we're good to go. Let's hit test. Problem here. Sorry, I've jumped into this. I got to exit out of that. The problem with it was it wanted a vector, and of course I gave it a line. So what I did was just switch it over to a vector, which I don't think I had to do, but I certainly had to go in and make this a type hint vector, not a line, even though the axis is a line. So that was a mistake on my part. You just have to think logically through it. You have to do what it's asking for. I wonder if I put my line in there, it still works. It does, so it reads the line as a vector, but that's just not good practice thinking that way. And of course, you can create your vector and change it. This line doesn't have to be hard-coded in like the way I did it by creating a line. I could actually go back in here and create another vector in the same way that I was creating this vector within the node. Hope that makes sense. Our outputs are not visual, but they're there. So our script's running, so nothing's there. It is giving us something. It's giving us data. It's giving us a vector. So it's giving us a length. So let's just... what a great node for jazzing you up and getting you some information. So let's just take this and do a quick copy here. The length does not have to be visualized, but the vectors do. So let's just copy a couple of these, pull them down here and say, okay, we've got a scaled vector out, we've got a reverse vector out, and we have a it's kind of a clumsy node, but we have another vector out. And of course, with those things, you'll want to go into display, give yourself a vector display, throw that in. Sorry, that's the anchor. We can anchor from whatever point we want. So we could leave that blank, but maybe just for consistency and thinking a little bit, let's take the anchor point to 0 on everything and pull the vector, not vector length out. Let's pull the vector unit vector out, and there it is. It's reading right there. It's a little tiny. It's a little angry at me. I should probably amplify it a little bit. That's a pretty small vector to try to get a look at. And that's where you might go into your vector tool and say, okay, I really need a little amplitude on this sucker. This is getting a little hard to see. So you need to bring that in and have a slider that you could really jazz it up. The scale will bring it up, definitely. But let me just bring that. Yeah, there we go. Now we got a pretty good amplification on that. All these are just data, so let's just pull them out of the way. Vector display there. I'm going to just grab this one. I'm not going to put it through an amplification. I'll take the point to the anchor, yes, and I'll just pull the vector right out for the scale. And you can see the scales happen. So there it is, and that is scaled like crazy because what is our scale value? It's 5.9. We don't have to be so crazy like that. Let's bring this back down so it's a reasonable scale, 1.6. And continuing right along, copy, copy. That should get us our last two from that anchor point. So do the vector reverse, and there it is in the other direction. Lovely. Making total geometric sense as you follow it. And the rotate vector on the angle. And now, that's the node that's pretty cool. You got a nice little node that does an awful lot of jazz, and there it is. And for me, I'm going to call it, the to the point, awesome vector node. And not the best name in the world, but that's just what I'm going to call it because this is just a test series. Copy it. Let's go into File, Create User Objects, the awesome vector node, put it into the icon. Sorry I go quick on this, but if you watch my videos enough, you'll appreciate that I'm flying over it. And there it is. We've got another vector node that pops in here. And we can do some jazz. Let's see if V is for vector node. Come on. I never have, like, if my luck, vector node. This is awesome that I always pick the last one. So what I can do is just grab this data down here, copy it, pull it down here, and say jazz, jazzy, jazz, jazz. And what I do with my patrons is my patronage is I give them my these nodes as user objects. Anyone that's in the red, or actually any nodes are on there, whether it's the C nodes I constructed or the Python nodes I constructed or anything I did. So that's a nice little node. It's working. You can take it out. You can pull it into this data if you want. I think this is a little clumsy big, but that's just the nature of it. Vectors kind of stretch out. I do like to neaten up my Grasshopper scripts, and you'll notice I write very little scribble tools and notes to myself, which is good practice for coding. And actually, I don't even go into here and write an awful lot because these are not complex enough to really require any notes, hashtag notes to what I'm doing. But anytime I run into problems, I might do that. So let's just save that one. There's the Wickerson node, all kicking, having fun. And the other node I want to make with you is right here. So let's take the visualization off of all this, disable that one. Let's go ahead and make the next node that probably is helpful. And that one is going to be a vector function. Let's call it vector function 2, which seems like a good name for it. Create one. You will be doing similar things. Let's open it up. Let's do our import. And these are the two nodes I would say get up on your desktop. You don't have to sign up for my Patreon to get the files. You can just follow along with these videos. What we're going to have is a vector A. Hopefully that makes sense. And I'm going to set that as a vector in the, I should just import a vector and call it a vector and bring it in and work it outside. But I think it's not going to kill us to X, Y, Z. And we'll do a vector B equal to A, B, C. And now you've got two vectors that you can hard code in to this node. And because they were numbers and I was using C, A, B, C, and then I'm also going to have A, B, C. You got to input all these things. So it's a crazy node for two vectors, kind of sloppy. You can find a way to do this, whether you want it to be a vector that's brought in just as vector 1 and vector 2. That'd probably be easier, but then you're just dependent on people knowing what to do in Grasshopper to get things up and running instead of numbers. So X, Y, Z, we'll pull it into a float. And it's very easy to leave these as, I like to have my nodes processing floats, booleans, integers, things like that to start. I don't like to have to go in and bring geometries in. That's kind of like having containers that hold things on the Grasshopper canvas, and I try and avoid that as well. And the more and more you try and script, the more versatile these become, and you can always change these things up. I think it's running. Let's just grab a little 2.0 and run that into here and do that about 6 times. 1, 2, 3, 4, 5. And that way we can build from these two different vectors that, of course, they're not going to read like vectors like that. It gets us some plugins. Gene pool would be a nice little tool to play with this, and sometimes I do that. So let's just set our Y high, our Z. Let's set our X high, our Y low, and our Z high. And that should give us two little vectors that have been constructed, vector A and vector B. So yeah, you got to write that in once, and then you can start playing. So the other functions I want to play with is vector add, and we'll call that out. We'll do exactly what we did in the other one. We'll set that to a RhinoScript function, which we will get to. We will have a vector subtraction, and have that as an out. And we will set that to a RhinoScript function. And then we're going to have the two big ones that I've started to visualize and really find the importance. And I never liked too much algebra math, and I did, but if you're going to get a cross product out, you're going to realize what that does between two angles that are orthogonal or like the same vectors. The angle between them goes perpendicular at 90 degrees, and it's at its height. And then its longest length. If this isn't making sense, that's okay, because you're going to start visualizing the vector cross product out. And we're also going to have a vector angle. I should do dot product as well, but let's just do vector angle equals, set to out as well. And that's going to be set to the angle RS. So that said, we grab all these, we hit copy, we go into here. We're going to need 4 things because we're building a pretty versatile, cool little node, and we'll customize it, make it our own user object. We're going to do the vector subtraction, same way. There we go. And we're going to do the vector cross product. And that's going to make this node look pretty long if you have full names. Oh, come on. There we go. And then we'll do vector angle out. And that should be it, with any luck. And of course, we will, with those vectors, add, subtract, cross product, angle. We will have to bring in probably vectors. This will be a nice little tight little vector there. And we'll have 2 of those. And then the last one will be a vector angle out, which would be a number. So you can see how we can just play into that. So let's just get these out, and hopefully our script will run beautifully. And since it says more down here, I'm getting the habit of not even using my out. What's the process? What are we going to use here? We're going to type in vector add, because we know probably in RhinoScript that that's available to us. Not vector add, vector add. And that should come up, and that's going to ask us for vector 1 and vector 2, which is not too hard. And we will just process that as vector A and vector B. And that should give us some data. Let's go into the next one, hit dot product, notation. We're going to go to vector subtract, and there it is, just autocomplete. That is asking for a vector 1 and a vector 2. But in order to do the subtraction, the trick I'm going to do is do my vector B first and my vector A second, just to keep it in the right direction of what I want to do. Now, of course, the very next step will be going in. I'm not doing a reverse, I'm doing a cross product. So vector cross product, and because I probably put a comma there, vector cross, there we go, autocomplete is going to ask for vector 1 and vector 2, and we can go back to vector A and vector B as the order, and you can switch these up if it's facing the wrong direction. The best thing about cross product, you'll just grab it, because cross product is going to come out in both directions perpendicular to the 2 vectors that are making it, and you may have to have them in one direction or maybe in another. You think about that as kind of flipping directions on things. And then vector angle is going to be vector angle. I thought we already did that one in the last node, but we're doing it here anyway. Angle. And that is going to ask for vector 1 and vector 2 as well, so we can just leave that as vector A. I don't know why I'm typing vector, and vector B. With that, let's see if we test anything. We've got no data collected because A is not defined. Aha! I called it UVW. Forgot to change this to A and B. And it's always nice watching somebody's video the first time, because you see all their mistakes and you're like, if you go back and watch it, like, look at them, they're so in the dark and ignorant. There's all our vectors. There's everything that's happened. Let's just get those straightened up and pull it down here, and let's do a little vector display to see what's going on. And this is why I do it, because if you can't visualize your vectors, there's your vector out. I'm going to throw on another point just to keep it at the 0. Mind you, you can put it anywhere you want. Mind you. And let's just see where that one's going. Very tiny. Once again, go into your vector tab, give yourself a little amplification. You can work that into the script. It wouldn't be hard to amplify something and have a multiplier through it. The vector is going to be amplified, and I'm going to just jazz it up by 3.0, which is like a scale. You've done it in a different way, And amplitude, I really messed that up. Amplitude vector up here. And that should allow us to, oh, that's such a tiny little guy. Let's take it up to an edit and bring it up to 100, 200, crank it up there. There we go. Now we have a nice little vector that we're playing off of. And we're going to grab the subtracting vector. And there it is, and it's tiny, so we're probably going to do that again. Amplify that one, amplification of that vector through that amplification, and set that to the, and there we go. We've got that one driving off in another direction, which is the subtraction of one vector to another. The trouble is we're not really seeing vector 1 and vector 2. Doing here, don't think I'm going to do that. I was just playing around a little bit. We'll get back to what it was. Vector add, everything should be running. Test, vector. These were the two that I took out. I don't need anymore. Just try to visualize some other information, but let's just finish up with this one. Let's take two more. Put it to the amplification, the cross product vector, and the angle doesn't need to be visualized. It was actually just the number. And so that's it. So we've got the vectors that are, sorry, I'm getting them out of order here. I don't even think we need to see them because I've actually visualized them. So there's the little script. That's how it kind of runs. I could neaten it up a little bit with a little bit of jiggy jag. So you've got the two vectors to start with. You've run it through these scripts. You can play with what they are, the X, Y, Z, and that might be nice to kind of visualize vector A and vector B just to see what that is. And let's just jump in here and see what that, let's put those back in for a second. And let's just see what we're getting from vector A. What's that actually telling us we have? And that is trying to give us 3 points that will make up the vector. So if we did that the same for vector B, it's a strange way to write it, I know, but that's just ends up what's happening. We'll grab a little bit of data as to what that is. Vector A is giving us 1, 2, 3, and vector B is giving us, if I hit Control Shift, that's interesting that it did that. Probably don't want to do that. I think I just want to get those as the points that will feed x, y, z for a vector from 0, 0, 0, if that's where we begin from. That's a good vector reading out to us, and then I'll just copy that over for the b. Now, if you can visualize that, that should be enough. If you had to do more with it, you could take vector b. Why is that only giving me y, a, b, c? Strange that that's all having an effect. Yeah, there it goes. Something was buggy with that. That it was just giving me one digit. So now you actually have the data that's driving. And if you wanted to, break that up and have a look at what was in that, let's see if we can just get over the sets and do something to allow us to see tree statistics, maybe tree branches. The branch, sorry, just playing around here. It's been a while since I was in here. Tree statistics is going to tell us the paths. What's that going to give us? It's going to give us the paths. So 0, 0. It has 3 in length, and the count is 1. I'm probably not going to need all that, but it would be nice to just have a point. So let's go in, and I'm just thinking off in another direction. If I took these, and I'm going to do something fun just because my mind wanders, and I always think about what would happen when I start using these tools. Let's flip this matrix and take these as X. That will flip the data and put 1 in each column. And what I can do is probably tree data now has been changed to 1s on each branch. So I actually could take each branch as a list item. Oh, I don't even know why I'm playing with this, but when your mind starts to wander, you start to play with this and have some fun, like a list item going in 1, 2, and then you have your, you probably wouldn't have to flip the data. You could just go directly in from initially what was there as a list. I wouldn't need that. And you should play around a little bit like this when you're in here because it's kind of fun. And then I'm building a point from there, there, and there. And there's our point that's actually making up the vector and where it was going from initially from 0, 0, 0. So I don't know. Just kind of let my mind wander here a little bit as to what the outcome would be and why I would do something like this. I'm making these two little scripts for the just so I could visualize like where the initial points were going. And that's kind of interesting to think about that. If I wanted to draw the geometries, like I said, you should get into stuff like this. From these points to these points might be nice, and do it again from this point to this point. And this is only, sorry, I want to go from the 0, 0, 0 because that's the start point to the end point there. And then I have these 2 points that are fine to just go in and make my my third line in the middle. And now I have the geometries that I can play with, and I can visualize kind of these 3 as I play with the, and I guess I could bring my amplification vectors down and zoom on in here and think about, okay, those were the 2 initial vectors, and how I can change those with the XYZ coordinates to move those, and how the vector addition, the vector subtraction, and the cross product and the total angle between them is all readable as I do that. So you end up, having a post and pre-grasshopper things happening in your node, but the node itself is, what did I call this one? Vector add. I think I gave this one a name. We called this one something, awesome vector node, and so this will be our to the point awesome awesome vector node squared. Oh, where's that little tool? Where's that little monster? Always tricky when I'm trying to find it. I'm just going to do squared like that. Maybe that's wrong, but either way, just something to have a little playfulness with. We've selected it. Let's go in and find our create user objects. And I do meander. I do wander. My mind is, my hands very rarely are doing what my mind is telling it to do, because, logically, the geometry you're seeing in the Rhino viewport is usually not the geometry that I'm seeing in my head while I'm thinking computationally in the Grasshopper window. So that's just the nature of it. Let's jump back in here and say we just added one that was pretty cool. Hey, I picked it first on the first try. I'm so happy. And so now this is a good time to Control-Shift-Edit, Control-Shift-Edit. And you will have to get a hold of these nodes if you want these to run. Control-Shift-Edit, Control-Shift-Edit, Control-Shift-Edit. And now, as we move this one up and delete this one, we'll override it with all these awesome types that we plugged in and the floats. And we have our great geometry. And you kind of have a little device that if you wanted to have fun with the endpoints and put a sphere on them and you wanted to pipe all these other things and merge them, this is usually what I do at the end of a class just to get people having a little fun in sets. Oh, really kind of losing my mind lately. I think because I'm getting so far into this stuff, it's easy to lose your mind. So my first 3, 1, 2, 3, and then my cross product visualizations, those are only visualizing vectors, so there's no real stuff there. But I can always grab those, and I can grab the points and another merge tool just for visualization purposes. Some people do this. That's the next one. And did I mean to do that? No, I meant to grab this one. And I want to grab that initial point there. So now I've got the balls for visualizing what I'm doing, and hopefully they're not huge. There they are, and I've got my little pipe of what I want to do here, and we can bring that radius down to half of the other one. So we'll just choose whatever, 2.9 as a radius for the spheres, and we will do a little multiplier in the math tools, division by whatever. We can divide it by itself. Actually, we can divide that by this and get our 1 factor, which is kind of a fast way of doing it, but making it relative, and there we go. There's our two little objects, and now you can get into more complex grasshopper scripts of how to Boolean union these and break these apart as to when there is a connection, where they intersect, and how to do a really fast process of making these Booleans without requiring on the Boolean nodes. But that's a whole other story. Right now I'm just having fun with this geometry drives the relationship between this and the two vectors that are being constructed by the x, y, z, and ABC points. So it's a little toy to understand math, to understand vectors, to start thinking. And when you start applying this to planes and to surfaces and rotations and axes, you're going to realize that, yes, vector math is terribly essential for getting to understand what you're trying to do. So this node is a nice little node written here. Oh, my little daughter says she can't hear. And the other node we created was over here. And those are your two little function nodes that are going to come in real handy for starting to understand vectors and starting to move things and doing attractors and all this stuff. Thanks very much for watching this very long, essential video.